Okay. Yeah. So we are going to discuss how we are going to implement the feature is mass integration and how it's going to be the database designed. Like this morning, I was talking with Andreas about the problem and how is our proposed solutions. That right now we have one idea that is propagate all the services, like all the information, and another idea is to use a catch table. Um, and yeah, and Andreas, I'm not sure if you already have something to share because you told me that maybe you have some ideas related to that.
Yeah, I was after our call, I was playing around with the model for that. That's perhaps something we can look at. I don't know. There is pretty sure there is something that I'm missing, or that there were missing edge cases. But we could perhaps look at this and then figure out what we're actually missing from that, or if that's a solution for us. Will that work?
Yeah.
Yeah.
Okay, good. Let me share my screen. And I can walk through that real quick. I would hope you see my terminal. Do you?
Yes.
Okay, good. Just increase the font size a bit. If I manage to find the right settings, sorry about that. There we go. Okay. So what I ended up playing with is basically, or maybe let's start from the other end. Basically, there is JSON B in Postgres, so you can actually use JSON values, JSON documents in Postgres, and there are also good functions around that. So you can work with JSON pretty nicely in Postgres. And basically, I've been toying around with a solution that is based on this idea. So when we talk about integrations and their settings, my understanding is that we basically talk about JSON documents or key value pairs. So we don't know upfront what kind of settings those integrations have. So we need rather something more generic. And in case of JSON B, what you can do is you can actually concatenate JSON documents, and that's basically merging things, so merging one document with the other, and thereby also overriding any keys that are already present in the former document. So in this example, we basically have two key value pairs here, and then we merge that with another document overriding one of these. So this exists over here as well, and then we add another key, and the result of this is, I think, what we'll need for service integration. So what we see here is basically this would come from a, I don't know, instance level setting, basically having A and B configured, and then on a lower level setting, we override A and we add C. That makes sense. And then as a result, we see basically the overridden setting for A. We see B, which comes from the top basically, and then we see C, which is the one that we added. Does this make sense in terms of in that context? So is that what we basically want in a very basic fashion?
Sorry, Andy,
sorry, I was just about to say yes. Yeah, basically that's what we want. Yeah, go ahead.
So my question would be, because I mean this would mean obviously I need to write like a SQL query that does this thing. How, and the problem that we are going to face, not in the first iteration, but in the future, is that we basically need to do like a hierarchical lookup, right? Mm-hmm. So if you have like a setting on the group level, you want that from the group, and if not, go back to the instance level. So if you have a project that's like 4 subgroups deep, you essentially would need to make that join or that union, or however you want to call it here, over like five groups, and the question is like, is it how well that would writing this interact with the Rails code? Do we need to write these custom queries everywhere? Is it, do we need like stored procedures or more advanced SQL stuff? I don't know.
That's a good question. Obviously we can do that in also in Rails, let's say. So you could do that sort of merging and all that in Rails. But turns out you can also do that in Postgres, and I think it's fairly easy to do that. Perhaps we can walk through that solution as well. But in general, and correct me if I'm wrong, but that's my understanding of the idea, is that we have this tree of settings, basically tree of JSON documents, if you want to follow that approach, and then one of the access patterns that we have is when you look at a particular project and you want to know what is the actual settings for this integration for that project, right? And what you do is on an abstract level, you basically go into that tree and you find the path to the root node. So thereby going from project level to group levels, perhaps a couple of groups, and then you reach the instance level. So you have this path in the tree, and then what you do is basically you start from the top at the instance level, and you go down, and then you apply this, what we just saw with the JSON merging, right? And you merge the more specific documents together, and you end up with a document that is basically the setting that you have for the project, right?
Yeah. How performant is this? Because the settings. And please, Arturo, Andy, you're the backend engineers. I'm just how performant would this be? Because if I imagine I have this like 3-4 groups down, I would have this select. How problematic would it be? Because we probably would need to do that querying like all the time. Would we then start like, how would we solve that problem? Because if you have like a project like GitLab, right, potentially every commit, every merge request is firing like an update where we need those merged settings essentially.
Mm-hmm. Should we first look at the how to query and then talk about the performance of that?
Sure.
Okay.
Maybe one more question about how to query. I think what we also sometimes do is like we want to find the service where A is 1, for example, but the actual service on the project level, it says A is A, and then the value gets overwritten from another level. So yeah, that would be interesting to see how we could query for that.
So querying for particular settings which integration has username equals foo or whatever.
Right. Like and then it could be that this username is the actual setting is actually coming from another level, from the instance level, for example. Mm-hmm. And but we still want to find the level on the service on the project level where the setting would be overwritten.
What is the feature behind that? Also finding a particular integration setting that has a particular value?
So for example, one of the settings is, I don't remember exactly what the name was, but I think it was, you can set when the service should fire. Like for example, there's like a checkbox and it says like active on commits or something like so. When we do a new commit, the project would search for services where commit events. Commit events, right? Yeah, commit events. Mm-hmm. Where commit events is true, and then like call the service.
Okay. Let's keep that in mind. That's another access pattern, I think. So
okay. Yeah.
When you approach this, I think it's good to think in terms of access patterns. So what is a parameter to the thing you want to do? Like So something where you come in with a project and you want to like get all the settings for this project, for the integration, or like you just explained, like searching for a particular config value. That's kind of another exit pattern. Let's keep that aside for the moment. I'll quickly show how the hierarchy works in that case. So what I ended up creating is a table for integrations, very simple, as a primary key, models the hierarchy with parent ID. So that is similar to what we do with namespaces, basically referencing the parent. Obviously the root level, instance level integrations, they would have null as a setting here, or as a key. Adding a type, but that's basically saying that we have like different types of integrations, Jira and other stuff. Just as an example. And then we have settings. This is the JSON-B document, and I've added a bunch of other things to make it a bit more explanatory. So looking at the table, this looks like that. Perhaps a bit confusing in this display, but you have the an instance level integration setting with only specifies URL, and then we have group level settings. Basically on the lower end, they reference the so this one is referencing the root level setting, adds another username, and then one level below, another group setting overrides the username, and I think we end up with this as a leave. So this is a project level, which overrides password and username, and then you would expect that basically seeing the URL coming from the instance level and then the password and the username on the bottom. And so basically you have to traverse the tree or build that hierarchy up. We can do that. I have an example here. Basically on a recursive query, you start from the leaf level. So in this case, we go for the project level setting here. This is ID 4, and we select everything, and then 1 as a level. And this is basically how many steps you're away from the leaf node going up to the root node. And then this is the recursive part. Again, selecting everything. Then level +1. That's the recursive step. So increasing the level. And we just join that against integrations on the parent ID. So this is just really just walking the tree from the leaf to the root node. Let's see how that looks like. So as we expect, we see the project level setting at the bottom, and then there is a group level, and then the instance level. So this is the whole path to the root level, right? And now basically we just have to apply the concatenation of those JSON-B documents somehow, like we did in the beginning. And I haven't found, but maybe I'm overlooking this, but perhaps there is even a standard JSON-B function for that. I have built my own. You can also do that. So basically defining a aggregate function, because it's really what we want to do. We want to like query this. We want to aggregate the JSON documents together, like you would sum a column. You can also aggregate other stuff, and in this case, those are JSON documents. And the aggregate function is basically the concatenation of this. And perhaps I'll just paste that in here, maybe on the top. What you can do is creating an aggregate function. So this allows you to use JSON-B merge as a sort of user-defined aggregate. You tell it to start with an empty JSON-B document. It operates on JSON-B values. So that's only the data type. And then the only thing you have to provide is an accumulator function. So that is basically how do you aggregate 2 JSON-B documents. And this is what we have at the top. We basically have a function for 2 JSON-B documents. And then the only thing we do is really what we did in the beginning with the concatenation. We concatenate the 2 of them, right? And then you have this JSON-B merge function, and we can do the same thing as we did here, but just apply the aggregation step on top of it, just pasting that in here. So this is the recursive part again, same as above, and then we select from all levels, or sorry, from this result, and we just apply ordering. So we want to order from the root to the leaf node. This is important because the aggregate function works in a particular direction. So you want to start from the root node and then add as you travel to the leaf, and so that's why we add the ordering. And then we just apply JSON merge, selecting from that result. JSON merge is the function that we have defined earlier, and that's how it looks like. So you have one document as a result, contains all the keys and the values, and we see that URL propagates from instance because it's never being overwritten on a lower level. And then this adds username, but the username is actually overwritten over here. So what we see here is the actual username that's being overwritten, and also the password is being set at the very last. So this gives us I think that's what we expect as a result, right? Does that make sense, or do you have any questions on that?
So
it looks great. Like
yeah, it looks really nice. I have a couple of questions because some of the integrations are using a separate table. Before we have, I think we already have for some integrations an attribute that is properties. That I think that is a JSON storage. And my understanding was that we are moving away from that for any JSON for different reasons. For example, we cannot encrypt values like passwords, or it's more like more inefficient. So, and for that reason, some of the services are using a separate table. For example, we have Jira tracker data in order to track the different fields and attributes. And I'm not sure if we are moving away from JSON and now we are like kind of introducing again, if we are going to have problems related to the use of JSON or the encrypt passwords or things like that.
Mm-hmm. I don't think we're moving away from JSON. At least that's news to me in a sense. I think we should be careful introducing JSON for the right reasons. So we should avoid that we use it all over the place and end up with a non-relational database. But for the right reasons, I think we're still good to just use it. We're just discussing it in other areas as well for more modern modeling approaches, let's say. So I'm not sure what would stand against that. If we have a problem with the encryption, that would make sense. The problem is that you don't get the I guess you can't encrypt individual fields in the JSON values automatically from active record like you can when you use attribute encrypted in a model. Is that the problem?
Yeah, I think that's the problem. Like we use the attribute encrypted. I think that's actually a gem that we use. And I think it can't handle JSON-B, but maybe there's a way to do it. I mean, like the JSON fields, they actually act like an attribute on the model. So maybe a way to do that in JSON. But we probably need to update it more, do some hacky things.
Yeah, but that's a good concern. I mean, we have to encrypt those passwords, perhaps other stuff.
Is it, I don't know anything about the JSON-B stuff in Postgres. Would it be possible to have, is it just plain JSON, or is it like JSON enhanced with, you could have like foreign IDs in there? So theoretically could be the password be a foreign ID that points to the encrypted table?
So yeah, yes, you can have pointers to other tables in there in a more abstract sense. So you would just put integers in those key value pairs instead of the actual data. From a modeling perspective, there is no foreign key mechanics for that anymore. So what you typically get from foreign keys is the consistency guarantees, and that's not possible with JSON-B.
So you basically would save like an integer and then just resolve it in that recursive function, kind of.
Yeah, kind of. I would try. So if that's only about the encryption, I would really try to encrypt the value and then store it in a similar fashion like we did here, because that's encryption. That's an application kind of problem. You don't want to do that in the database, and then it's really just about storing the encrypted values instead of the non-encrypted ones. So the model, the model would look like the same, but you would just store the encrypted values.
Yeah, makes sense.
And so that's like the typical access pattern where you want to get the service with the values with all the inheritance. And before you said there's also this other access pattern where we want to get the actual values that are stored in, like, without the inheritance. How would that work?
So how would it look like in this example? Are we so perhaps interested in finding all integrations that have this URL set, or can you come up with an example that we can look at?
I was thinking about the more simpler one, like when you want to get the actual settings that are stored in the service. But maybe that's actually really, really simple, because we just would select the service where ID is 1 and then just get the settings. So yeah, okay, this one might be very simple. And then
so this is what we did here basically, right? We were looking for service 4, and then this is the parameter that we have, and then we get the settings for that. Did you mean that example?
No, I meant like when we want to get the. Oh wait, let me quickly have a look.
But after we get this merge, JSON merge, are we going to store that, right? Because then any different scopes that we have, they are looking for things that satisfy, for example, like merge events is true, or commits events is true, or things like that. So at the end we need to store this JSON merge on the normal relational database, right? With in a normal service. You know what I mean? Like, this is for me more to calculate what is the final thing, and then we want to store that final thing in a service to be able to make queries around that.
That would be kind of a denormalization, in a sense that we represent that data in the tree, and then we calculate something, and then we store it to calculate the results somewhere else. That makes me think that this is an optimization, kind of, perhaps for a particular access pattern. But I would suggest that we try to, first of all, not do any optimizations until we until we're sure about the model, and then see that we actually need that. So can we talk a bit more about how that access pattern looks like? Well, my understanding is that basically something happens on the project, you have a commit, and then you're basically looking at the project and you want to get the list of services that you have to notify because of that commit. Is that the
Yes, yeah, exactly. So there would be a setting called commit events, and if that setting is true, we want to notify the service.
Mm-hmm. So basically what we're saying is that we could have multiple of those or different types of integrations, right? We would have Jira, some other issue tracker, whatever. And for those, they have the idea if they need to be notified if there is a new commit coming in or so. So depending on if the service is sort of interested in a commit, we would consider it or not. Is that something that we would have to represent in that tree as well? So is that something that you can configure on a project level?
Yes. So let's say like we want all the services to be notified on commit, and we want to have this, like we want to define that on the instance level. So if you would add like commit events true to the instance level setting, and this would be like, yeah, all the other services would inherit from that.
Can they override the setting? So groups or projects?
I think they can. I think they can also set it, like override it to false.
Yeah, they can.
Okay.
Okay. Isn't that then basically the same thing as dealing with those settings, so that you would basically have another column with a JSON-B where you have
basically
those flags?
It's the same as any other setting. I just wonder how we would access it, like how we would get if we would query for the service that has commit events true, and it's only set on the instance, but we actually want to get this project level setting.
Mm-hmm.
I mean,
oh, okay, now I see. Yeah,
it would be kind of in your example, like you have the data right now. If you would query, give me all the projects that have like username foo, right, in the end result, like, or have the URL world.
Yeah, right. So if we in that example, if you would query where URL is world, and then this should return all the services because they are all inheriting from the instance.
Right. Do we always have a project filter in this case? So by in this example, we would say this is basically our project filter. So we're looking for. It's not that you look at all the integrations and you want those which have username foo across the site, but you're basically interested in a very narrow scope for a particular project with a particular setting.
Yeah, I think at the moment this is how it works, because at the moment there's just project level settings, project level services. So we'd always have the project filter. I'm not sure. Maybe in the future we would have like a group wide trigger, but for now it's just project.
A good example is, for example, you make a commit and we trigger a hook, and that maybe you have two integrations. One is Slack and another is Jira, that is going to trigger if commits events are going to be true in Slack and in Jira for that project. So that is going to trigger at the end a Slack comment and a Jira comment in the different integrations. So at the end, what is doing the database is we have the project is looking for all the services that have a commits event true in order to do something with the final configuration of that integration.
Mm-hmm. I think as long as we have a narrow scope, so as long as we always come from a project and have this perspective, then I think that would work. If we don't have this and we sort of globally interested in finding all the integrations that have a particular setting, that would be a problem, because then you can index JSONB, but we're actually interested in something that is calculated across that hierarchy. So it's not really present in the table. So you would have to run this first, and then this is really a problem in that modeling.
Yes, but so that is the. So I think that is the problem, right? Because maybe you have commit 7 true at the instance level, and then you don't have like you need to resolve. You need to resolve what is for the project, what is the final commit 7 for the different services.
But wouldn't we just, because we need to do that recursive query here, wouldn't we just, where we have the where, I mean, we basically build this recursive table and then we query again, right, from that recursive table. Wouldn't we just put a where in there? So like the all levels as select star from our order by level descending, wouldn't we just put like a where commit events true in there? And then it should be pretty okay performance-wise, because you just, every time you have like the commit event, you build like this recursive table that just goes up all the levels, which would be like, I don't know how expensive that would be. And then you just select from there, right? So it would be as expensive as the normal query, but you just have like an additional filter in the final select. Sorry, my SQL days are long ago, so maybe I'm not wording it correctly.
So you're saying that basically you still have to go up that path in the tree, and we can do that with the recursive query. Only additionally, we apply a filter that sort of looks at this flag and says, or we only consider this when it's enabled.
Yeah, essentially I'm saying like, essentially I'm saying, hey, every time we need the services for one project, we would need to do the recursive iteration, right? And it doesn't seem like too expensive, right? Mm-hmm. I don't know how expensive it is. And if we actually want the ones that do something on a certain thing, like commit true, merge request true, a commit event true, merge request event true, whatever, it doesn't make the query more expensive, because you still have the recursive thing, and then you in the end just have like one more where clause, right? Mm-hmm. So I mean, the question would be on a scale like GitLab.com, how expensive would that recursive querying be? If I have like, let's say, like a project like GitLab, right, where you have like dozens of events every minute.
Right. We already have this on the namespace hierarchy, so we already do these recursive queries, and we kind of already know that they are not the fastest, but it's also not too bad, if I can put it that way. So what we typically see is maybe 100 and 200 milliseconds. That's something we looked at yesterday, I think, for working with the hierarchy for a GitLab project. That's obviously not the fastest, so maybe there are other ways of modeling that. But it's, I mean, we're dealing with a hierarchy anyway, so there are a few different modeling approaches you can do. A recursive one is perhaps the easiest one to work with, and it's not too bad performance-wise on Postgres.
Okay, so you are saying that right now, what I normally do is, for example, project.services where commit event is true. In that case, in order to resolve this, what we are going to do is do that like over the fly, you know, like do all the recursive resolution in order to at the end to know what are the services that have that settings equals true, right?
Yeah, let's see how that looks like. We could do, I'll call that just flags. So this is really just the same, adding a JSON document, and then we can perhaps I don't know the correct wording, but I'm just going to go with that. So we would have something like this, right? And then you could disable that on certain levels, or have different kind of settings for that. What was our example again? So we were looking at 4. So for example, we could say we disable this on the leaf node. So this could mean so now this is false on the bottom, and then JSON merge flags, and we would get this the very same thing for those flags, and then we would just say in the end for JSON flags, or we can wrap that in on commit equals false. Yeah, but modulo the syntactic sugar, but basically works like that, right? So first you calculate all the things, all the settings and those flags across the tree for a particular project, and then you just filter out the ones that you're not interested in. And I mean, how many integrations are we talking about for a project? So, manageable, or?
Yeah, so every project has
36 or something like that at the moment, but obviously enable are not going to be like, maybe you have 5 integration enable, I guess.
Yeah, so basically, even if we have an event that only pertains to the ones that are interested in commits, not the others, we could still like calculate all the settings for all those 36 integrations for the project, and then just filter out the ones that are interested in a commit. So it's not ever dealing with it in that sense.
And if we like do another example, like let's say the leaf node doesn't have a value for on commits, so it should inherit this value from the parent.
Mm-hmm.
How would we query for that?
It's the same query because you built a table beforehand, right? So that's the thing you do with the recursive. That's the thing that we do with that recursive query.
So this is basically that example, right? So you have the leaf node, it doesn't have the setting, and you would expect it to inherit it from here.
Mm-hmm.
And in that case, yeah, it's the same methodology. You merge, basically this is in the right order already, so you merge those documents together, and the last one doesn't do anything because it doesn't have any key value pairs. So you just go with whatever comes from the top.
Ah, okay.
There is one caveat I just realized. Not really sure how to solve that. Let's consider the situation when you only have one record for the instance level, so not the other ones. When you do that query, you still want to get a result back, even though there is no specific record that is on this level, right? So you want to, even if there was only one, even if there was only this top level record, the same query should be possible, giving you back settings for lower levels, even though they're not present in the table. Is that correct?
The question would be, maybe we could work around that in a first iteration by always creating a record once you enable an integration.
Yeah, I think that in order to enable the integration,
we would just, because potentially our integrations would have like another, because you might want to disable integration as well, right? So it might make sense that you, for each integration, have like another column that says just like active, true, false. And then if you create a new project and it should inherit all the settings, you would just have like active, true, and the rest of the settings is just like the empty JSON. Because I think that's something where we're also a bit unclear, because we don't have the feature yet, and we are a bit unclear about the UX. If it, for example, is in use case, to automate, if you create the settings on an instance or a group level, do you actually want to create it for all projects, right? Mm-hmm. Or not, or should you still enable it? Or
I already asked about that. Yeah. So how it's going to behave is you have a new instance, okay, and you have 100 projects, and you haven't configured like any integration. If you go to the instance level, and there are two options, right? Apply to all the projects these settings, or apply only for the projects that are inheriting the settings. So in one case, you apply that to the 100 projects. So that means that maybe here we need to create the records for all the projects that are going to be empty. Like, in settings is going to be an empty hash, or an empty JSON in this case, for 100 projects, and you only have the settings at the top level. And in the other case, because if you only want to apply to the projects that are inheriting the settings, in that case you cannot apply to anyone, because no one is inheriting from the beginning, So in that case, you only save the settings at the instance level, and that's it. And you don't have any other settings configured. So basically, in order to enable an integration, at least you need to create a record with something, even that everything is empty, but you have to create the record. There are two functionalities. Sorry, go ahead, Andreas.
Actually, I'm thinking that the hierarchy itself, this is kind of present from the namespace hierarchy, right? I mean, we add an instance level, and then on the bottom there is the projects. But with that in mind, I don't think it's an actual problem that we would need to add all the records on the project level, even if they were just inheriting from the top. I think this is something I think we should avoid, because there is not more information coming from that, right? You just inherit from the top anyways. And consider, for example, we would enable an instance level integration on GitLab.com for all the projects. Would we add millions of records to that table for each of the project, add one record? So that's, if we can avoid that, I think it would be good. And perhaps separating the hierarchy information from the setting information, and then using the hierarchy to build up the tree, and then joining that with the config setting is a way to go. And then you don't have to add leaves that only inherit from the parent anyways. But it's sort of always built on the idea that if you go down the tree, this is additive for the JSON document. So it's not possible to say that basically at a certain point in the tree you discard what you already have and you start from scratch. So you completely override what you have in a certain part. That's a problem in that approach. But my understanding is that we always want to add as much as we go lower in the tree or towards the leaves, right?
I mean, you still could theoretically override everything, right? Because on a group, I could just set every setting and then the instance level thing would be discarded or not taken into account in the actual join, right?
Okay, good point. Yeah. That works. Mm-hmm.
You always have the two options, like override everything, like you modify the URL, for example, and you have the option like override everything that is below me, or only override for the integrations that are inheriting that setting.
Mm-hmm. And the other topic we talked about earlier, Arturo, the visibility and then also disallowing overrides. Yeah. I think that would sort of work in the same way as it does with flags, for example. It's just another flag that you add and you merge that down in a similar fashion. And then we keep it separate from the settings information. This is something that would help us basically in the user interface to display that you can't override the setting anymore at this level, or also in the backend to say, wait, well, this is not allowed. So we make sure this way we make sure we don't get the inconsistency in the data. But it's a way to keep that separate.
There are other, yeah, I see that this functionality is going to work the same. There are other functionality that we have that is list all the groups or projects that are overriding any of the settings. So for example, you are the admin, you go to the instance level, and at the bottom you want to see all the projects that are overriding any of the settings. I'm not sure if how we can do this with this design.
Couldn't we just then query everything? So we would need to build the hierarchy, like get all the sub projects, and then we could just query every setting that has an actual value set. Because if the JSON would be empty, you would, yeah. Mm-hmm. So in the example we have here, we could theoretically, if you query, hey, give me everything where the JSON is not empty, and then you have all the values, have all the projects that override something, right?
Right. Or even by sheer, depending on when we insert in that table, but you could also say by sheer presence of records in this table, they are overriding something for the service. Otherwise, they wouldn't be present if that's something that we have. Is that also possible on an instance level? Basically, admin looking at the instance level settings and seeing all the projects that override this? Could be quite a lot, right?
Yeah, to be honest, I think this is also like an advanced feature that's that's not like part of the MVC. It's the UX designer has drawn this up. Hey, I want to potentially see all the projects that are overriding a setting. I mean, especially makes sense if you think about the migration, right? You have services right now. You're happy about this new cool thing we've built in your group or on your instance. You want to start enabling, the one true Jira integration. and it would be cool to find like all the projects that are overriding it, right? So yeah, but I don't think it's necessarily. I mean, it would mean that we need a new query strategy for that anyway, right? Like
maybe the query could be like for project services where the JSON-B field is empty, and so or basically where the JSON-B field is not empty, then we know they're overriding something.
Yeah.
What I would suggest doing is, so if this meets our functionality needs, taking that model and then using some production data, or we could use the data that we have for GitLab.com and then simulating that a bit. So loading that model once, playing around with that a bit and seeing how those queries perform. I think it should be fine. Like it's really standard traversal from getting the path to the root node, and the rest of it, like the JSON merging, that's not really a performance issue, because you retrieve those nodes and then you merge a few things together, but that's not a real problem. So I don't think it's too concerning, but it's probably good to test around with that.
Okay. So, yeah, we are like out of time. So basically, my main ideas that I get from the meeting is that we want to move from like to store everything that we need to keep track over the hierarchy. We need to move into a JSON blob, right? In order to do this how we call it, the resolution basically on the tree, right? So we want to move all the properties into a JSON blob. I posted, for example, one of the issues and one epic that we are like other people is working at the moment is move from the properties JSON serialized properties fields for different reasons. I think one of them is to using the attribute encrypted, but we need to see if we can resolve that. And yeah, so this is the main idea, right? And then so maybe we can think a little bit more about this, if it's possible or not. But sounds very promising.
The encryption part is perhaps the biggest blocker in that regard.
There's a gem called Attribute Redactor, which says it can do the field encryption in JSON blobs, but yeah, we'll need to see if that actually works.
Cool. And I mean, alternatively, you can always have the same model in the database and then do the JSON merging in the application. It would work the same way, but you'd retrieve a bit more data from the database. But it's still not that we're dealing with a lot of data that we can't consume in the application, I guess. But it would be nice to do it in the database if we can.
Yeah, would be more expensive because we need to query more, right? We send like 7 queries then if you have like a deep project, and this way you send 1 query and potentially the database optimizes like a thing in the right?
What I meant was you can also use the recursive querying and all that but don't apply the aggregation in the database, and you basically retrieve all the path in the tree and you load that into memory.
Okay.
Then you do the decryption maybe, and then the JSON merging in the application.
Yeah. That makes sense.
Yeah, if we can do it in the database, why not do it there?
If we know how to do it, because maybe you have much better knowledge that we have about, doing something on the database. So, for example, one of the features is restore from admin. You overwrite one of the settings and you want to restore what is the setting coming from the parent. So we also need to do another recursive query, right? Going to your first group, then the next group, then the next group, until you reach maybe the instance level, right?
Why? If you want to restore, you would just set the current projects to empty, and then your query would get the yeah. That's actually the nice thing about the solution, right? Yeah. If you ever want to delete something, I mean, one of the problems that we have UX-wise is if you ever go into a group level and delete like values, that you essentially delete everything, change the values for everything below it as well, right? So if you go into a group and say restore to instance level, this might be potentially problematic because you can break stuff. But I think that's more of a UX problem than a database problem.
Just one quick question. You build the tree with parent ID. In our case, we don't need that, right? Because, I mean, in some way, we already have the tree that is, a project know what is the group, and then the group is a namespace. So, I mean, do we need to use that column, or we can infer that what is my parent in a different way?
That's a good question. I think we should be using the namespace hierarchy for that, because otherwise we would duplicate that information. That might be difficult.
Yeah.
I don't have a good answer how to integrate that into our approach here.
Okay, we can maybe explore that. It's just one of the things that I see, and it's like, okay, we need to do this. I'm not sure if we have to keep a tree actually with IDs, or maybe we can use our current namespace and then infer the information in a different way.
Right. Yeah. It kind of works nicely on a greenfield. And now, how do we do that? And how do we integrate that into GitLab? Yeah. Good point.
Okay, I think that's. I'm going to say that like we are over time, and we don't want, for you, like maybe you have other stuff to do, but maybe we can start to think in different ways to resolve these problems, the encryption, and this how we resolve the tree actually, or if we need to do something else. But it was really nice to have the JSON blob idea, and it was really nice.
Yeah,
cool.
I think it's pretty cool.
Glad it was helpful. But let me also say, like, this is just a suggestion, right? You have to be comfortable with the model as well. You're the ones making that decision. Just it has to work for you in the end.
Yeah. Cool. Okay.
Okay, good.
Thanks a lot.
Thank you very much.
Thank you. Sure. Have a nice day.
Thanks. Bye.